This is the Boeing 737. Practicality, economics, and versatility are the defining characteristics of this plane. Since its introduction in 1968, it has had a great impact on commercial aviation. The 737 is a versatile workhorse, a multi-purpose powerhouse, a highly efficient cash cow, and a very reliable airplane, a reputation it has built over 50 years. So, how did it get here? Welcome to this Dwayne's Aviation video. Back in the late 50s, jet travel was becoming more popular, and the demand for a true short-haul airliner was rapidly increasing. Boeing had the 727, but airlines didn't exactly like it because it had 3 engines and it needed 3 pilots to fly, which means it was not exactly the most economical choice. The 727 wasn't exactly a bad airplane, but the problem is that Boeing made several compromises on the design. They wanted to develop a jet airliner to serve smaller cities with shorter runways and less passenger demand. At the same time, they wanted to satisfy United Airlines, which wanted an aircraft with more than 2 engines for its flights to high-altitude airports, especially its hub at Stapleton Airport in Denver. Also, they wanted to satisfy American Airlines, which was already operating the 4-engine Boeing 707 and Boeing 720, but still wanted a twin-engine aircraft for efficiency. Eastern Airlines, on their end, wanted a plane with 3 engines for their overwater flights to the Caribbean because, at that time, twin-engine commercial airplanes were not allowed to fly 60 minutes away from a diversion airport. But as soon as the 727 came to the market, sales weren't exactly good. Several airlines preferred to buy the twin-engine Sun Aviation Caravelle. Douglas was still certifying the DC-9 at the time, and pre-orders were promising. It was at this point that it occurred to Boeing that they needed to design a true short-haul airliner. Preliminary design work for the 737 began on May 11, 1964, with an initial concept that featured podded engines on the aft fuselage, a T-tail as with the 727, and 5 abreast seating. This was no different from what Douglas, Sud, and Fokker were already working on. Boeing knew that in order to dominate the market, they needed to come up with something better. So engineer Joe Sutter, who led the 747 design, relocated the engines to the wings, which lightened the wing structure and simplified the fuselage construction. This modification made it possible to widen the fuselage to accommodate 6 abreast seating instead of 5 in the rival designs. The engine nacelles were mounted directly to the underside of the wings without pylons, allowing the landing gear to be shortened. This made the fuselage lower and more accessible to load baggage and passengers. Relocating the engines from the aft fuselage to the wings also allowed the horizontal stabilizer to be attached to the aft fuselage instead of as a T-tail. Normally, certifying a new design takes years, and Boeing can't afford to lose the market to BAC 111 or the Douglas DC-9. They saved production time by using 60% of the structure and systems of the existing 727 and 707, the most notable being the fuselage, which differs in length only. The wing airfoil sections were also based on those of the 707 and 727, but this time Boeing made them thicker and redesigned the engine mount section, which helped the 737 achieve a substantial drag reduction at high-speed cruise. The engine chosen was the low-bypass Pratt & Whitney JT8D, which delivers 14,500 pounds of thrust. When the 737 came onto the market, it was hot. Every airline wanted it. The first generation, the 737-100, could only seat about 85 people in two-class configurations, and there was a problem with the thrust reversers, which were taken straight from the 727. They proved to be relatively ineffective and tended to lift the aircraft off the runway when deployed. This reduced the downforce on the main wheels, thereby reducing the effectiveness of the brakes. Boeing fixed this problem in 1968 by redesigning the thrust reversers and making several other modifications that gave the aircraft a boost in payload, range, and improved short field performance. When they moved to the 737-200, they stretched the fuselage to accommodate more passengers and cargo. After some time, they improved aerodynamics, included automatic wheel brakes, more powerful engines, more fuel capacity, and hence a 15% increase in payload and range over the original. Boeing also offered the option of what they called the gravel kit feature, which enables the 737 to operate on remote, unimproved, or unpaved runways, such as gravel runways, giving it access to a much wider range of airports. Following the success of the Boeing 737-200 Advanced, Boeing wanted to increase capacity and range, incorporating improvements to upgrade the plane to modern specifications while also retaining commonality with previous 737 variants. So, they started to build the 737 Classic series. The 737 Classics are the 737-300, 400, and 500. They re-engined the plane with the high bypass ratio CFM56 engine, redesigned the wing, and made it larger in area. This resulted in greater fuel capacity, better fuel economy, longer range, and higher takeoff weights. It was also equipped with a glass cockpit, and the interior configuration was also upgraded, making it possible to seat 108 to 215 passengers depending on the configuration. The 737 Classic sold and sold. Boeing was winning the market share even more and more, but at a point, the new Airbus A320 family became more efficient, so airlines wanted it instead, and this was a serious threat to Boeing's market share. Boeing needed to improve their plane to keep up with the competition, so they moved on to build the Next Generation series. The 737 Next Generation, or the NG series, includes everything from the 737-600, 700, 800, and 900. Boeing again upgraded to the more efficient CFM56-7 engines, redesigned the wing again, then made cabin and cockpit improvements. This set them back on track with their competition with Airbus. Then, in 2010, Airbus struck again. They announced the A320neo, and this time it would be 15% more fuel efficient, which would make airlines a lot of money. Following the introduction of the A320neo, American Airlines announced a large order for 460 aircraft, a whopping $38 billion in list price. 260 of those will come from Airbus, and Boeing will deliver the rest if they make a more fuel-efficient 737. It was clear that airlines wanted a more efficient small plane and fast. This made Boeing executives very worried, and they needed to act fast. To compete with Airbus, Boeing had to make a crucial change to the aircraft to achieve better fuel efficiency and range. To achieve this, they needed to install the new CFM LEAP engines under the wings of the 737. But the 737 is close to the ground, and the engine is a lot larger than the previous ones, so there wasn't enough room under the wing to slide a new engine. Back 50 years ago, when the 737 was designed, the proximity to the ground was a conscious choice. It was a feature that made it easy to load and unload backs without a conveyor belt and maintain engines without a lift. This simplified operations for the less developed airports of that time. The proximity to the ground was no problem for the first generations of 737s because their engines were long and thin. For the second generation, the 737 Classic series, Boeing moved the engine forward and up and designed its intake as non-circular to achieve more ground clearance. The next generation also kept this design, but then for the 737 MAX, the engine got much bigger than the wing could accommodate. A few months later, Boeing's product development team found a way to get a bigger engine under the wing. Their solution was to move the engine up and slightly forward so that it would fit on the 737. This compromise came at a huge cost. Moving the engine up on the 737 had some side effects. When the 737 was at full thrust, like during takeoff, this made the nose point far upwards, which could lead to a stall. Boeing solved this problem by installing a software that automatically pushed the nose downwards if the plane tends to point too far up. They called it the Maneuvering Characteristics Augmentation System, or MCAS. They didn't mention the new MCAS system in the training material, and it cost hundreds of lives. The reason they decided not to mention it is that pilots are generally trained to operate just one type of aircraft and not a specific variant. For example, some pilots fly the 737, some fly the 747, some fly the A320s. A pilot that flies any 737 variant at all can easily switch to any other variant of the 737 without substantial training, as long as the other variant flies and behaves the same as the previous ones. So, this means that an airline with different variants of the 737 can switch pilots between those variants on any given day without having to send them to training. The reason American Airlines wanted a refreshed 737 over a new plane was because they already had a lot of trained and certified 737 pilots, and they were not willing to spend a massive amount of money training their pilots on a new plane. Boeing knew this, so they decided not to mention the MCAS, because in order to sell the 737 MAX as the same plane as the previous 737s, they needed to maintain that the 737 MAX flies the same way as the older ones, giving airlines the impression that crew training is not required. As a result, pilots only got a 2-hour iPad course before entering the cockpit for the first time. The MCAS is activated by input from only one of the airplane's angle of attack sensors, making the system susceptible to a single point failure. So, when the system senses the aircraft's angle of attack is too high, it will automatically rotate the horizontal stabilizer to cause the aircraft's nose to ditch down. But if this sensor is broken, it can cause the aircraft to think that it is flying at too high of an angle and self-correct. Unless the system is deactivated, it can keep pitching the aircraft down until it crashes. This is the cause of the crash of Lion Air 610 in October 2018 and the crash of Ethiopian Airlines 302 in March 2019, and is also what led to the grounding of every 737 MAX in the world. Boeing said that the way to disable this was to turn off the automatic stabilizer trim and pilots were supposed to somehow know this, but these crashes proved their assumptions to be totally wrong. It took Boeing over 1 year to fix the problems and improve pilot training in August 2020. Finally, the MAX was cleared to fly again in November 2020, with American Airlines making a demonstration trip. The first commercial service flew on December 9th with Brazilian airline Gol from Sao Paulo to Porto Alegre, and American Airlines flew the first U.S. service on December 29th. United Airlines resumed services in February. Southwest Airlines, the type's largest customer, followed in March. The Boeing 737 family has been successful for a number of reasons. Firstly, passenger service is only profitable if you can actually sell the seats. Larger planes, like the A380, are harder to make a profit with because carriers need to sell more seats to break even on the flight. The 737 models are relatively small, so carriers don't need to sell as many seats to make a profit. Most models with the 737 family can fit between 100 and 200 passengers. Each route only has a finite amount of demand from passengers. You can sell thousands of seats a week on routes like New York to London, but you can only sell a few hundred from Florida to Atlanta. Since larger planes cost more money to buy and run, running larger planes on less popular routes is not profitable. Smaller planes like the 737s, in contrast, are more likely to be profitable on smaller routes. There are thousands of routes where you can't make money with larger planes, but you can make money with smaller ones. So, smaller aircraft cost less per route and can be profitably used on more routes. These factors make the 737 family popular with traditional carriers. However, the biggest chunk of 737 sales is to budget airlines. Budget airlines like to minimize their fleet diversity because it means you don't need to spend as much money on training, maintenance, or parts. It reduces losses due to mistakes, and it allows for saving money via bulk orders. Budget airlines can remain cheap by maximizing the usage of their planes, which means that they want to maximize the variety of routes they can fly in order to avoid cannibalizing their own sales. Since the 737 family can be used for more routes than any other Boeing plane on the market, the demand for it is a lot higher. Southwest Airlines prototyped modern budget aviation as we now know it, although they didn't take the model to the extremes like other carriers did. Many modern budget airlines copy the Southwest business model down to minor details. Southwest, with a few exceptions, runs exclusively on 737s because they know they can sell the seats, and they own more than 700 of them. Ryanair, which optimized Southwest's model for a different market, also runs exclusively on 737s. In summary, the 737 family is successful because one can reliably make money with it and integrate it into most networks, and because there's an entire subsection of the industry that prefers planes in that capacity range. If you like our videos, please smash the like and subscribe button. You can also join us by clicking on the link next to the subscribe button. Thanks for watching.